Hi students, in this lecture we are going to learn electrostatics. So what do you mean by electrostatics? So here we are going to study about static charges. So first understand what is the meaning of charge. Let us see here. Suppose I am taking here a body which is dropped from a height h, or you can say any height from ground. So we can see that the body moves down. So why it moves down means Earth is pulling that body, or you can say the body is experiencing gravitational force because of Earth. For example, body is not having mass. If this body is not having mass, then there is no gravitational force, right? And we have learned at school level, mass means it is amount of matter present inside. But now at this 12th class level, we are giving a slight grown up definition. That is, mass is one property of a substance, or we can say particle, or we can say matter, which is responsible for gravitational force. I am repeating, mass is one property of a particle, or we can say a body, or we can say a substance. Mass is a property of a substance which is responsible for gravitational force. If that substance is not having that property, then it won't experience gravitational force. In the same way, substance is having one more property called charge. So it is one more property called charge, which is responsible for electric force or magnetic force, or we can say combinedly electromagnetic force. So I'm repeating, charge means it is a property of a substance or of a body, or we can say of a particle, which is responsible for electric force, magnetic force, or combinedly electromagnetic force. So because of this property, a body is going to create electric field, or the body is going to exert electric force or magnetic force, or body is going to experience electric force, magnetic force. So this is a property. This is the property of a body, which is responsible for electric force as well as magnetic force. Okay, right. And we are knowing that charge of electron is negative and charge of proton is positive, and both are having same magnitude. And we are knowing that an atom consists of equal number of electrons and equal number of protons. That means an atom is electrically neutral. I am repeating. Atom consists of equal number of electrons and protons. That means atom is now electrically neutral. And if you take any substance that consists of atoms, that means a substance is electrically neutral, right? Now, if an atom is ionized, so ionized means maybe adding electrons or removing electrons from atom. If we remove electrons from atom, then that is a having positive charge. So removing electrons means body is having positive charge, right? So whenever a body is having positive charge, its meaning is it is having deficiency of electrons. Suppose it is added electrons, then it gains a charge, means it is now negative charge. So when we are saying a body is having negative charge, we have to keep in mind it is having excess electrons. And in this, if you observe carefully, Charge of a body. We are saying we are charging a body by adding electrons or by removing electrons. That means charge of a body is always integer multiples of a charge of electron. See carefully. A body is charged. Its meaning is either removing electrons or adding electrons. Therefore, charge of that body will be integer multiples of a charge of electron. Okay. Where n is an integer, it can be positive, can be negative. Because if you are adding electrons, then q will be negative. Then taking n is negative. If you are removing electrons, then q will be positive and n is positive. Okay. And this property is called quantization of charge. I'm writing here quantization. Or you can say charge is a quantized. So charge quantized means charge of any body is integer multiples of charge of electron. So how we can expect questions based on this. Suppose we are given charge of a body. It is now calculated. Now question is, does this charge exist? It means is it possible? Then what we are doing is we are dividing out this charge with a charge of electron. If we get integer, what is it? If we get integer, then that charge is a positive. So like this, we can expect questions based on quantization of charge. Okay, right. So here what we can conclude is that charge is negative, means mass is increased because adding electrons. Charge is a positive. Its meaning is electrons are removed. That means body's mass slightly decreases. Right? Okay. Let us see few basic properties of charge. So the way we have given here definition for charge. It is the property of matter which is responsible for electromagnetic interaction. So this is a combined one because electric field, magnetic field, both are same. So known as electromagnetic field. Okay. So writing combinedly here, electromagnetic interaction. This is the definition part for charge. And charge of electron negative, that of proton positive. Coming to units, Coulomb, name of a scientist. So notation must be capital C. Otherwise, in terms of current, ampere second. So capital A, name of a scientist, and second. And dimension formula is for current ampere and for time it is T. Okay, right. Now see some properties of charge. Charge is a scalar quantity. You know what is the meaning of a scalar? Charge is a transferable. Means we can transfer charge from one body to other body. That means let us say initially one body is neutral. Now that can be made either positively charged or negatively charged, right? So it can be transformed. And third important point, charge always associated with mass. That means charge cannot exist without mass, but mass can exist without charge. This is one important point we have to keep in mind. Next, and these two points already we have discussed, right? Now see fourth point, charge is invariant. So invariant means charge is not change. So here our intention is charge is the same, whatever may be its speed. That means if a charged body is moving, its charge does not change with the velocity, even though speed is comparable to speed of light. Okay, that is the meaning of charge is invariant. Okay, right. Now see next one. Charge is quantized. This has already been discussed, right? Charge is quantized. Its meaning is charge of any body is integer multiples of charge of electron. So where n is positive or negative integer. And next point, in an isolated system, charge is a conserved. Means if you are taking one system, charge is a constant. So what do you mean by this? I will give an example here. Suppose we are taking here H plus added to Cl minus. See now for this system, what is a charge? This is a plus and this is minus. So for the system total charge is 0. So when these two are added, see what we get here, it is HCl, right? And its charge is 0. That means when you are taking a system, for the system, total charge is a constant. The meaning of charge is a conserved. Okay, right. Next one important point, that is the seventh point. Like charges repel and unlike charges attract. Its meaning is like charges in the sense, if you take two positive charges, they repel each other. If you take two negative charges, they repel each other. That means if you take two electrons, they repel each other. If we consider two protons, they repel each other. Unlike charges attract. That means if we consider one is a positive charge, other one is negative charge, they attract each other. That means between electron and proton, there is attractive force, right? And if you want to calculate what is that magnitude, that force of attraction or repulsion, direction and its magnitude, that we can calculate by using Coulombs law, right? Let us see now what is Coulombs law. The electrostatic force between two stationary point charges in air or vacuum is given by F bar equal to K into Q naught by R cube into R bar. It's the explanation part for this. So here we are focusing force of attraction or force of repulsion between two charges, and that is given by Coulomb's law. So we are taking two stationary point charges in air or vacuum. So taking one charge, that is a Q, other one it is a Q naught, other one is it is a Q naught. So we are focusing now what is a force by Q1 on Q2. I am repeating, what is the force by Q on Q naught? Then what happens is, if both are same sign, means both are positive or both are negative. If both are positive or both are negative, by Q on Q naught, it is repulsion. That means it will be away from Q. Force is like this. So we have to show like this when we are taking the free body diagram. Okay. If Q and Q naught, they are unlike charges. That means one is positive and one is negative. Then Q attracts Q naught. Then we are writing that keeping arrow towards Q, because we are focusing force on Q naught. That's why drawing the arrow from Q naught towards Q, attraction. Away from Q, it is repulsion. Let us take now the distance between those two is R. Okay. Then force by Q on Q naught is given by F bar equal to, it is K Q naught by, it is R Q into R bar. When we are focusing force on Q naught, then R bar represents position vector of Q naught with respect to Q. I am repeating, we are focusing force on Q naught, right? Then R represents distance between those two. R bar represents position vector of Q naught with respect to Q. Okay. Now see carefully. If Q and Q naught both are same sign, means both are negative or both are positive. If both are negative, minus into minus becomes a plus. Then direction of F bar is direction of R bar. See what it means. Force by Q on Q naught will be along R bar. It is repulsion, right? It is repulsion along R bar. Suppose one is a positive and one is negative. Then plus into minus, it is minus. So minus R bar. That means a force is opposite to R bar. Its meaning is force on Q naught by Q is opposite to R bar, like this towards left side. That indicates it is attraction. That means when we are taking force in vector form, we have to substitute charges along with the sign when we are writing vector form. That means if you are given position vector of Q, position vector of Q naught, then R bar will be, let us take position vector of Q is R1 bar. Position vector of Q naught is R2 bar. Then position vector of Q naught with respect to Q, that is given by, I am writing that as R bar, which is equal to which is equal to, it is R2 bar minus R1 bar, right? This is what we have learned in vectors, right? R bar equal to R2 bar minus R1 bar. Otherwise, I will write here once again. This C is a Q and this C is a Q naught. Let us take origin somewhere here. Okay, right. Let us now consider the position vector of Q1 is R1 bar. Position vector of Q2. Position vector of Q2. I'm taking different color to make it clear. Position vector of Q naught. That is R2 bar, right? And we are focusing now force on Q naught by Q. So focus on a position vector of Q naught with respect to Q. That is R bar. So now by using vectors R1 bar plus R bar minus R2 bar equal to 0 bar. I am writing here vector equation R1 bar plus R bar minus R2 bar. Why minus means? Because we are moving. So here along R1 bar, here along R2 bar, but here opposite to R2 bar. opposite. That's why minus R2 bar. That is equal to 0 bar. Bar is important, okay? It is a null vector. So from this we got it is R2 bar minus R1 bar, right? So this is the vector form of Coulombs law, okay? So when we are taking vector form, we have to take charges along with the signs, right? Okay, now coming to here, what is K? So K is a constant which depends on the system of units we are taking. And in this chapter, we are focusing only SI system. And in that system, K value, I am writing here, K value, it is 1 by 4 pi epsilon naught. And its value is 9 10 power 9. And you can guess here units of K. This is a force, Newton, R cube, and this is R. So this is R square. So what I can do here, Newton meter square, Coulomb into Coulomb, right? Coulomb square. It is a Coulomb square. That is the value of K in SI system, right? Okay. Now in that we can see one more thing, that is epsilon naught. Epsilon naught is known as a permittivity of free space or air. Epsilon naught, permittivity of free space or air. Its value 8.85 10 power minus 12. And you can see units from this one, epsilon naught. Units are Coulomb square per Newton meter square. Okay, right? So this is expression for force of attraction or force of repulsion between two charges when they are in air or vacuum. But if we place these charges in some other medium, then how to calculate is, and that is given by, so in the place of CF bar, what we are writing here, if we are placing in some other medium, so we are going to write it as F bar equal to, it is 1 by 4 pi epsilon. Here we have taken epsilon naught, that is permittivity of free space or air. Now in the place of epsilon naught, it is epsilon and remaining as it is, that is a Q naught by R cube into R bar. And coming to here epsilon, epsilon is permittivity of medium. I am repeating, epsilon is permittivity of medium and its value is epsilon R into epsilon naught. And we know what is epsilon naught. Coming to epsilon naught, this is epsilon by epsilon naught, means ratio of permittivity of medium to permittivity of free space. And that is what we call a relative permittivity. That is what we call a relative permittivity. So this has no units because ratio of same quantity. Okay, because these two have same units. That's why this has no units. And this is also known as dielectric constant of that medium. Okay, let us see notes for this one. Right. So R is the distance between the two charges and R bar is the position vector of Q naught with respect to Q, because we are focusing force by Q on Q naught. Okay, right. And see that K value 9 10 power 9 and units and the value of epsilon naught. It is known as permittivity of free space or air. If charges are placed in a medium, then F bar equal to 1 by 4 pi epsilon, right? This is what we have discussed till now. I hope you got it clarity.